GCP Platform and Cloud Engineering Part 3. This episode has 17 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Behavioral. Describe your experience with cloud platforms, Kubernetes, Terraform, and DevOps. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 2. Production readiness. How do you approach infrastructure changes in production to minimize customer impact? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 3. Python or automation. How have you used Python for DevOps automation in real projects? Here's a strong way to approach it. I use Python mainly where automation needs structure, APIs, error handling, and maintainability. Examples include calling cloud APIs, validating Kubernetes manifests, generating reports from logs or metrics, checking IAM or security posture, automating deployment checks, and building small internal tools. For a senior DevOps role, I do not treat Python scripts as one-off files. I add configuration, logging, retries, dry run mode, clear exit codes, tests for critical logic, and documentation so the team can run the automation safely. Alright, next question. Question 4. Python or automation. How would you design a Python script to automate repeated cloud or Kubernetes operational tasks? Here's a strong way to approach it. I would first define the exact operational workflow and failure modes. Then I would design the script with configuration through environment variables or a config file, argument parsing with argparse or typer, structured logging, input validation, and a dry run option. For Kubernetes I would use the Kubernetes Python client or call kubectl only when that is the team standard. For cloud operations I would use the official SDK. I would make the script idempotent, add retries with backoff for transient failures, return meaningful exit codes, and run it in CI. Cron job, cloud run job, or a controlled automation runner. Let's keep going. Question 5. Python or automation. How do you handle errors, retries, logging, and exit codes in production Python automation? Here's a strong way to approach it. I handle expected errors explicitly and fail fast on unsafe conditions. For transient errors such as API rate limits, network timeouts, or temporary 5xx responses, I use retries with exponential backoff and a maximum retry limit. Logs should be structured and include operation name, resource name, environment, correlation ID if available, and final status. Exit code 0 means success, non-zero means failure, and different exit codes can represent validation failure, authentication failure, or partial execution. For production automation, silent failure is dangerous, so failed runs should alert or create a visible ticket. On to the next one. Question 6. Python or automation. When would you choose Python over Bash for automation? Here's a strong way to approach it. I choose Bash for simple command orchestration, such as running a few shell commands in sequence. I choose Python when the automation needs API calls, JSON parsing, data transformation, complex conditionals, tests, reusable modules, better error handling, or long-term maintainability. For example, a 5-line deployment helper can be Bash, but a tool that checks Kubernetes resources, queries cloud APIs, builds a report, and applies conditional remediation should be Python. Good. Here's another one. Question 7. Python or automation. How would you securely handle credentials and secrets in a Python automation script? Here's a strong way to approach it. I would avoid hard-coding secrets or passing them through command history. In cloud environments, I prefer workload identity, service accounts, managed identities, or short-lived credentials. If the script needs a secret, it should read it from Secret Manager, Vault, AWS Secrets Manager, Azure Key Vault, or the platform-approved secret store. I would avoid logging secret values, mask sensitive fields, restrict IAM permissions to least privilege, and rotate credentials. For local development, I would use environment variables or a local credentials flow, but never commit secrets to Git. Nice. Let's continue. Question 8. Python or automation? How do you make Python automation idempotent? Here's a strong way to approach it. Idempotency means running the automation multiple times should produce the same final state without causing duplicate or unsafe changes. I do this by checking current state before making changes, comparing desired state versus actual state, using stable resource names, avoiding blind create operations, and making updates conditional. For example, before creating a Kubernetes namespace or IAM binding, the script should check whether it already exists. I also add dry run output so reviewers can see what would change before execution. Great, moving on. Question 9. Python or automation? How would you schedule and run Python automation in production? Here's a strong way to approach it. It depends on the use case. For scheduled operational jobs, I can run Python as a Kubernetes cron job, Cloud Scheduler plus Cloud Run job, GitHub Actions, Jenkins scheduled job, Airflow DAG, or a VM cron if the environment is simpler. For production, I care about identity, logs, retries, timeout, concurrency control, alerting, and auditability. I would also prevent overlapping runs if the automation changes shared resources. Alright, next question. Question 10. Python or automation? How would you package and deploy a Python automation tool for a team? Here's a strong way to approach it. I would package it as a proper Python project with PyProject TOML, reusable modules, a CLI entry point, pinned dependencies, tests, linting, and versioning. For execution, I might publish it as an internal package, build a Docker image, or run it as a CI or CD job. The team should get a clear command interface, examples, dry run mode, and documentation. For sensitive automation, I would add approval gates and least privilege runtime identity. Let's keep going. Question 11. Fast API. What is Fast API and why would you choose it for backend APIs? Here's a strong way to approach it. Fast API is a modern Python web framework for building APIs. I would choose it because it is fast, developer-friendly, supports async, uses Pydantic for validation, generates open API documentation automatically, and integrates well with testing, authentication, containers, and cloud deployment. For DevOps or platform teams, Fast API is useful for internal developer portals, automation APIs, webhook receivers, deployment tools, and service integrations. On to the next one. Question 12. Fast API. How do you create a basic GET and POST API in Fast API? Here's a strong way to approach it. In Fast API, we create an app object and define root functions with decorators like @app_get and @app_post. A GET endpoint is usually used to read data, and a POST endpoint is used to create or trigger something. For request bodies, I use Pydantic models so Fast API validates input automatically. In production, I also add proper response models, status codes, error handling, authentication, logging, and tests. Good, here's another one. Question 13. Fast API or validation? How does request validation work in Fast API? Here's a strong way to approach it. Fast API uses type hints and Pydantic models to validate request path parameters, query parameters, headers, and JSON bodies. If a request does not match the expected schema, Fast API returns a validation error before the business logic runs. This is useful because invalid input is rejected consistently. For production APIs, I define strict models, avoid accepting arbitrary fields unless needed, validate ranges and formats, and keep request and response models explicit. Nice, let's continue. Question 14. Fast API or auth? How would you implement authentication and authorization in a Fast API application? Here's a strong way to approach it. For authentication, I would normally use OAuth 2, JWT, API keys, or an identity provider depending on the environment. In Fast API, dependencies are a clean way to validate tokens or API keys before the endpoint runs. Authorization is separate. After identifying the caller, I check roles, scopes, groups, tenant, or resource level permissions. For internal services, I may also use MTLS or identity-aware proxy at the platform layer. I would log authentication failures carefully without exposing tokens. Great. Moving on. Question 15. Fast API or database? How does a fast API application read and write data to a database? Here's a strong way to approach it. A fast API app usually uses a database library or ORM such as SQL Alchemy, SQL Model, Async, SYCOP, or a cloud-specific client. The endpoint receives and validates the request, calls a service layer, performs database operations through a session or connection pool, commits changes, and returns a response model. In production, I separate root logic from business logic, use migrations such as Alembic or Liquibase, configure connection pooling, handle transaction rollback, and avoid leaking database errors to clients. Alright, next question. Question 16. Fast API or async? What is the difference between sync and async endpoints in fast API? Here's a strong way to approach it. A sync endpoint uses normal def and blocks the worker while it runs. An async endpoint uses async def and can release control while waiting for non-blocking I/O, such as async database calls or HTTP calls. Async helps when the application has many I/O bound operations, but it only works well if the libraries are also async. For CPU-heavy work, async is not the solution. I would use background workers, queues, multiprocessing, or separate services. Let's keep going. Question 17. Fast API or testing? How would you test a fast API application? Here's a strong way to approach it. I would write unit tests for business logic and API tests using Fast API Test Client or HTTPX. Tests should cover successful requests, validation failures, authentication failures, authorization checks, database behavior, and error responses. For database tests, I can use a test database, transaction rollback, or containers. In CI, I would run formatting, linting, type checks where useful, unit tests, integration tests, and security or dependency scans. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.